Welcome to Study Loop.
Given number of mole of water, let it is represented by N is equal to 1 mole. Molecular mass of water, let it is represented by M, which is equal to 18.0 gram per mole. Initial temperature of water, let it is represented by Ti, which is equal to 100 degrees centigrade. Now we will convert it in Kelvin. So 100 plus 273. 273. Now it is converted into Kelvin, which is equal to 373 Kelvin. Initial temperature of vapor, it is given, so it is represented by Tf, which is 100 degree centigrade. Now we will convert in Kelvin. 100 plus 273, which is equal to 373 Kelvin. Latent heat of vaporization is given, that it is represented by L. L is equal to 2.26 into 10 to the power 3 joule per gram. Here water at 100 degree is getting converted into vapor at the same temperature. So we have to find the change in entropy, that it is represented by S. Now we know that S is equal to change in entropy. Delta S is equal to delta H upon T, where delta H representing the heat required to convert into the vapor. So M into L upon T. Here M is the mass and L is the latent heat of water. So here M is equal to N into molecular weight, and L is the latent heat, and T is temperature. Now we will substitute the value of N, M, L and T. So here number of mole is 1, molecular weight of water is 18, and latent heat of water, it is given 26, 22, 60, and temperature is given 373 Kelvin. So joule per Kelvin. When we will solve this, then we will get 109 joule per Kelvin. Now uh, we will look into the point B. So here change in entropy of water at 100 degrees centigrade, and it will convert into the vapor from water at the same temperature, will be 109 joule per Kelvin. Now we will look into the bit B. So here given for the bit B, it is given that number of mole of liquid nitrogen, silver and mercury all are of the same number of mole. So here let it is represented by N, number of mole of nitrogen is equal to number of mole of silver is equal to number of mole of mercury. All are have the same number of mole, which is equal to 1.0 mole gram per 1.0 mole. Sorry, 1.0 mole. Molecular mass of silver, that is represented by MS, which is equal to 107 gram per mole. Molecular mass of nitrogen, that it is represented by Mn, which is 28 gram per mole. And molecular mass of mercury, let it is represented by Hg, M of Hg, which is equal to 200 gram per mole, gram per mole. And latent heat of vaporization of nitrogen, let it is represented by Ln, which is equal to 0.201 into 10 to the power 3 joule per gram. And normal boiling point of nitrogen, Let it is represented by Tn, which is equal to 77.34 Kelvin. Similarly, for silver and mercury, let it is represented by Ls, which is 2.336 into 10 to the power 3 joule per gram, and temp normal boiling point of silver, which is 2466 Kelvin, and latent heat of vaporization of mercury, which is represented by LHG, is equal to 0.272 into 10 to the power 6 joule per gram, and let and normal boiling point of Hg mercury, which is equal to 630 Kelvin. Now we have to find the change in entropy of these three materials. Let it is let the change in entropy of nitrogen is represented by Sn, which is equal to delta H upon T. Here delta H for nitrogen is m into L upon T. Here m is mass of the nitrogen. So here number of mole into molecular weight into Ln upon T. So change in entropy of nitrogen is 1 into 28 into latent heat of nitrogen, which is given 201 into 10 to the power 3. 201 into 10 to the power 3 means 201 upon 77.34 Kelvin. So which is equal to 72.76 joule per Kelvin. Similarly, we can calculate for silver and mercury. S is equal to 1 into 107 into latent heat of mercury, which is 107, which is 2336, upon normal boiling point of mercury, which is 2466, that is equal to 101.35 joule per Kelvin. Similarly, change in entropy of mercury, delta S of Hg, which is equal to number of mole molecular weight of Hg into latent heat of mercury upon temperature boiling point of mercury, which is 272 into 206 upon 630. When we will solve, then we will get 86.6 joule per Kelvin. So here nitrogen is in liquid form and silver is in solid form, and mercury is lying between solid and liquid. So here final answer will be 86.6 joule per Kelvin. Change in entropy of Hg is equal to 86.6 joule per Kelvin. Delta S of Hg is equal to 86.6 joule per Kelvin. Now we will look into the bit C. So in C, we know that entropy is the measure of randomness. So the entropy of gas is higher than liquid, and entropy of liquid is higher than solid. So all are in the same order. So all are in the same order. Same order. It means change in entropy of the given material is 100 joule per Kelvin.